Hey James, so I was looking at this report and it talks about the global energy sector being quietly urgent. What does that even mean, really? Like, are we in trouble?
Right, Emma, it's a good question, isn't it? Quietly urgent. It's like the challenges are massive, but it's not a screaming emergency yet. Climate targets, yeah, but also how renewables are just exploding. And our old grid, well, it was predictable, wasn't it? Analog. Now it's a super complex, like real time puzzle. And traditional computing, it's backling, frankly. The models can't keep up?
Oh, okay. So the old systems are just kind of overwhelmed then. And that's where quantum comes in, I guess? Is it like going to be some big flashy overhaul or
No, no, not at all, actually. That's the thing. It's not fireworks, not shiny promises. It's focused, a different kind of power for big problems. Think optimization, simulation, proper forecasting, even cybersecurity. It's not about ditching everything, no. It's more about asking much more thoughtful questions of the system. It's about giving the grid the ability to, well, see itself, if you will.
that makes sense. So, practically speaking, where are we seeing this happen? Like in grid management, I imagine it's got to be a huge deal, right?
Absolutely, Emma. The grid, it's all about orchestration, isn't it? Decisions in milliseconds. And sometimes it's knowing what not to switch on. CERN, Classic, Wolfram Research, they're tackling it like a three-part symphony. And at Rochester Institute of Technology, they're actually redefining the daily heartbeat of a grid with quantum power. It's quite brilliant, really.
Wow, that's pretty wild. So it's not just about managing the existing flow. What about all these new energy sources, and like EVs?
Precisely. Real-time grid balancing, that's where quantum shines. It can listen to massive data streams, smart meters, weather, historical consumption, those unpredictable renewables, all at once. It's not about controlling chaos, it's about working with it. And electric vehicle charging, if you've plugged in at peak hours, you're part of the problem, right? Quantum reshapes EV charging schedules from bottlenecks. Pascal and EDF are co-developing tools to predict renewable fluctuations, helping reduce over-engineering. It's about finding that balance.
That's fantastic. So are we talking about like better batteries too, or is it all just about the grid management side of things?
Oh, it's absolutely about better batteries, Emma. Quantum simulations are helping design them, like right down to the molecular level. Lithium, solid state, all that. It's not just theoretical, though. In northern Spain, for example, Iberdrola and multiverse computing, they didn't just think about it, did they? They ran a real-world pilot, optimizing battery installation, cutting costs. Quantum didn't just model the future there, it actually helped build it. Pretty amazing.
That's so cool. And what about security? All this digital grid stuff, is it making us more vulnerable? I've heard about quantum safe cybersecurity, but I don't really get it.
You've hit on a super critical point there. Power grids aren't just physical anymore, are they? They're digital, and that absolutely makes them vulnerable. Future cyber attacks, yeah, they could even come from quantum computers themselves. So, quantum security is already in play. In South Korea, Nokia, SK Broadband, and KHNP are collaborating to protect their nuclear energy infrastructure with quantum-safe systems. When the stakes are that high, prevention, is truly the only defense.
It sounds like this is a really active area then, James. Is this happening all over the world, or are a few countries really leading the charge?
It's not one country's moonshot, Emma, not at all. It's more like a global slow burn, where the quiet players sometimes move the farthest. The US, with Oak Ridge National Laboratory and IonQ, they're actually deploying serious grid optimization. Europe's CERN is turning pure research into practical frameworks, and the EU quantum flagship, well, that's a declaration. Canada, D-Waves and Neelas are already at work on complex optimization. Spain, Iberdrola with multiverse computing, they're setting the pace for energy innovation. And Denmark, understanding wind volatility, is pushing quantum to tame turbulence. It's happening everywhere, really.
So it's happening everywhere, but it's not fully quantum yet, right? Like, what's the end game then?
Precisely. That's the twist, isn't it? It's not fully quantum, at least not yet. It's hybrid. Half classical, half quantum, all strategic. This isn't theoretical anymore, it's infrastructure level change. The problems quantum's built for, those NP-hard, multivariable, deeply entangled ones, they're exactly what the energy sector faces daily. As hardware stabilizes, software matures, we'll move from what if to what now. Quantum computing and energy, it's in its quiet phase, but trust me, that silence is loaded. It's the hum before the shift, the pause before the power flows, you know?